Next, we will move on to the actual operation of NMRFAM Sparky. So Sparky main menu, you can see that top part here is a main menu, and if you click one of them, you will see the sub-menu items down here. And as I mentioned, these two letters are the shortcuts you can type in inside of command window here or in the spectral view. Then if you move along these menu items here, you will see different sub-menus. Or there is a pop-up menu function. When you open your spectral view, you probably don't want to go back to this main window all the time. Instead, you can just simply right click in your view, then you can access other functions that you wanna use in this view directly. So let me show you here. In here, you can click one of them, and you can see the sub menu items down here. Then you can just click on it, or if you already memorized 2-letter code, then you can just type in this command window directly, like we did for capital R, capital E to change our Sparky home. So like I said, this part is command window. You can just type in the 2-letter code, and this is cursor window that will tell you what cursor mode you are in. So if you are in the select mode in the view window, you can select the peaks. And if you're in the center mode, if you click in the spectral view, that click position will be centered, and you can add lines and labels and find and add peaks. We will demonstrate that, and you can zoom into the specific area, and there are other cursor items that you can play with later. So if you go to the file menu, you will see two parts: open, save, save as, and then you see another open, save, save as here. So as you can imagine, top part is for a single spectrum, while this part down here is for project. So I mentioned, the project will have multiple spectra. Save files will be in a project file, and then each save file will have matching UCSF files. So you can save an open save file or open a UCSF file from top part of this menu, and then project file will be handled below here. You can open a project, save, and you can save as a new project name. So what we're gonna do first is to open a spectrum. So we already know about 2-letter code. So you can type FO inside of the command window, or you can click File and Open from this drop-down menu. And we will open Spectral Practice Spectra and NHSQC. So let's do this. You can go here, File and Open, or just type F4 and go to Desktop, Spectral Practice, Spectra, and NHSQC. When you are ready, and open it. So NHSQC spectrum has been opened like this, just like here in the slide. And we will make a save file. So we opened UCSF, which is just the raw data. Then we will make a save file that will save the metadata and analysis results inside for that experiment. You can use FA two-letter code or save as from the file drop-down menu. So we will use a unique name, anything besides nhsqc.save, which will be used later. So if you go back to here and type FA, you could do that from the file drop-down menu. Like I said, you can see that the default file name is following that UCSF file name nhsqc. But while we already have nhsqc.save, it will put 1 right here. But we don't want to be confused with this, so maybe we can name it differently, such as nhsqc_practice.save. I always encourage not using spaces in the file name, because in the Linux sometimes that space could be interpreted as the delimiter. So if you wanna really need to have some separation between file name, I highly recommend using underbar like this. Then save. You can see that saving nhsqc_practice.save has been accomplished. If we go to spectral practice and save, you can see that new file has been made. And we're gonna make a new project that will have that save file inside. So you can do either way, from drop down or type JA like I mentioned. So this time let's do it from here. File, project, save as. Maybe we name it just practice.poj. I always encourage you to keep that file extension as .poj to be assured that the file is project file. Then you will be asked if you want to override nhsqc_practice.save, because when you save project file, it automatically saves save files first and then save project file. While we already have that save file saved in this directory, it's actually overriding the file, but it's okay to override for us right now. So maybe we can select OK and don't ask again. So that means whenever we save project file, it will automatically save those save files first and then save project file. And when it saves save file, it will not ask. You see that backup file in case you lose your information automatically generated here. And then if we go to the project directory like this, new project file practice.poj has been created. So that means if you close everything and then go to File, Project Open, and you see project.plj. You can just open it, and it will open save files in the project. So if you have multiple save files, it will open multiple save files, and the conditions that you have set will automatically load it when you open your project file. So these are the things that we already done. Save the spectrum and open a project, save a project, and then we can open new spectrum in the project we already generated. So it's basically the same thing. So basically when you open save file FO and then save it, so these are the two letter codes that we have done. Before this, we used FO to open the UCSF file. And then if you want to add new spectra, let's say you have save file and UCSF, then you will use FO and then open save file while you already open your project, then save it. But if you only have UCSF and you don't have save file, still you use FO to open your UCSF and then save using FA or FS, and then you save project file, and then you just repeat it. When you generate a project file, you don't really need to make a new project every time. So every time you introduce new experiment into your project, you don't have to make a new project file every time. You just stick with the same project file. When you open the spectrum, just save as a save file, and then save the project file will contain that save file you just saved in a same project, so you don't have to make a new project. It will just add the new save over and over again in the same project file. And another thing that you want to make sure is that when you close your window, you have to be careful about click X button. So here is the X button here. It's gonna discard your experiment entirely from your project. Instead, you want to use other features such as PV or TV that will be introduced later. There is show and hide buttons like this, so you will use show and hide instead. So such as you click hide here, it's gone, but still it's in your project, so you can reintroduce that experiment easily by click show button, or you can just double click like this. It's gonna be a lot easier, but if you just click this X, then it's gonna be completely gone, so you can just open the save file again. But it's gonna be a little more work in case you have set some more features such as referencing and synchronizations and so on. So it's a little more work you need to do to set it up, so you don't want to do that. Okay, and I just showed that tree view and view list briefly. So we use tree view to show and hide the view. So if you open the tree view, TV is the two-letter code. When you type it, you will see this window. This is new feature recently developed, and it will show you the molecule and condition types of the experiment that you have, and then it will show you 2D, 3D, 4D experiment, and it will nest the experiment with the spectrum and views. I mentioned multiple views could exist for one spectrum, and this is the view associated with this spectrum experiment. You can have multiple views if you make a duplicated view using two-letter code VD, but by default you will have only one. And I showed how to hide and show the view. It's just a double click on it or click show and hide button here. And also you can access spectrum settings and view settings by right click on these items. So when you select this spectrum and right click or click the settings button, it will show you the spectral setting window. When you are selecting this view item and click this settings, it will show you view settings window. And another thing that traditionally used is the view list PV window. It will show you all the views in your project, and you can just double click to show and hide. Then it will show you the nuclei, data size, number of peaks in that view, actually the experiment, and assignment. We don't have any peaks and assignment in this experiment, so it is exhibiting zeros here. Like I said, you can go to spectrum setting and view setting by right click or click settings button. For this item NHSQC, this level is spectrum and this level is view. So select the spectrum item, click settings or right click on it. So right click probably on Mac, if you don't have two button mouse, it will be holding a command key and click, right? Instead, if you have the regular two button mouse, and you can just click using this right button, then you will see spectrum setting, like I said, because we are selecting this spectrum item. So when you are selecting this view item and right click, will open view setting. So there are two-letter code. Instead of going from this tree view window, you can type ST, spectrum setting, or VT. So it does the same thing. So if you don't want to go from tree view, you can just type ST or VT. But if you have tree view open here, you can easily access by just right click onto your experiment name. Okay. For spectrum settings, you will see the experiment that you have. You can rename it. If your file name is quite complicated, you want to have a shortened name, you can change here, and molecule and condition can be set here too. You can change. So let's say NHSQC is so you want to say backbone experiment, so you can just say in condition, you just say backbone. Then you will have different condition here. It's all up to you. If you have many experiments, you can use this function. If you don't have many, you can just go undefined as well. And ornament size, in case you have peaks, you can change your peak size. If you have labels, you can change your label size. But there are shortcuts that you can utilize. We'll get to that point too. Then while chemical shifts is a relative frequency from DSS, in case you collected data different temperature or different conditions, or just the magnets are different, well, there could be a little bit of difference between experiments. In that case, you want to align them. So we will do a short, brief alignment demonstration later. Then if you want to put something about your experiment, so let's say this one was collected by someone at some temperature and magnet was, let's say, 800 megahertz and so on and so on and so on, you can describe in here. And in the view settings, if you have multiple views, your view settings will differ. Then aspect ratio, so what actually you see is a 2D. Despite you have 2D, 3D, 4D, you will see only two dimensions at the same time. And depending on your aspect, so if your aspect, so now NHSQC, you have proton and nitrogen here, and then the frequency, let's say ppm range is quite different. Nitrogen is a lot larger scale compared to the protons, so you want to change it to see it more circular peak shapes. So this is the parameter for doing it. So if you just use 1 ppm, that means 1 ppm in X is same as 1 ppm in Y dimension, and that will make your peak very narrow because nitrogen and proton exhibit different scale. So we are using 10 ppm, but you can change it depending on your interest and depending on the experiment that you have acquired. And other options that you can play with in these view settings. And other useful commands: zoom in and zoom out, two-letter code zoom full, so it's gonna show all full extent of your experiment, ZF. Zoom in is a little larger step compared to using plus key or mouse wheel. And zoom out, ZO, is the same thing. You can use minus key or mouse wheel instead for a smaller step, but it does the same thing. And zoom up or zoom down, in case you have 3D experiment, you will have additional panel below at the bottom, and you can move around up and down. So the way it shows 3D data is you see 2 dimensions in the window. It visualizes a 2D, but additional 3D will be at the bottom as a planes you can browse into. So you can change your plane level by using ZU and ZD. And in case you want to enable or disable, or you want to change your mouse wheel direction for zoom in and zoom out, you can just type MW. And another zoom in function is drag to zoom in to some part of your spectral region, F11. So let's go back to your NHSQC. Here, F11. So while you are in zoom out mode, you can just drag some part like this. That part will be the new extent of your spectral view. And like I said, you can zoom in and zoom out by ZI, ZO. Or you can type plus or minus. It's smaller step and you can feel it more continuous and use your mouse wheel. If you are a Mac user, you have to be careful. There is a mouse wheel acceleration feature in the Mac OS. So if you just use wheel aggressive, then sometimes you will get to the position that you don't see anything like this. Or it could be too small, like this. Admirably, in that case, you can just type CF to make it a full extent. And another thing that you see in the cursor, two things will be noticed. One is a mouse cursor icon. So it will tell you what cursor mode you are in here. So you are in zoom mode, then you see that magnifying glass icon is there. If you are in select mode, you see different icon with that X mark in it. And you also see the chemical shift value in yellow text. In case you want to hide it, you can change here from the view settings or two-letter code FC. You can just turn that off. It's no longer there. If you want to use it, you can just re-enable it and you see that too. So view settings are all kind of these settings. So this is the quick shortcut cheat sheet for NMRFAM Sparky. So some of them, such as tree view, spectrum property, and then VT is another thing that we covered, and the icons. So F1 select mode, F11 zoom in, you see different icon, and then actually F8 will be another one that you will be using for find and pick picks. Actually it's same as when you are in the select mode, you hold your control key, it works as F8. So actually you don't really need to change in case you are jumping over from select to find and then vice versa. You can just stick with the select mode. Instead you can just use control key to find picks. And there are other useful control associated shortcuts such as select all picks when you hold control and control A. So it's same as Office program. You can select all the writings in the Office by control A. So when you do that in the NMRFAM Sparky, it's gonna select all the picks. And saving is control S. Control D is deleting a selected pick. Finding is control F. Copy and paste control C, control V. And changing the pick size, control J and K. Label size, control N and M. So you will get to that point when actually using these features. And contour level could be changed by semicolon and single quotation mark. If you hold your shift key, you are telling the Sparky, okay, I'm gonna change contour levels for negative signals. The contour gap, contour line gap will be adjusted by brackets too. So like I said, ZU and ZD could be replaced by comma and dot. So it looks more natural that you see this direction greater than less than marks will tell you which plane you are going. Okay, we will get to that point. We will use this quick shortcut. So let's try to change the appearance of NHSQC that we have. So we already have view setting. You can just type VT or you can go from tree view. what we're gonna do is just changing the color to white and disable this frequency on cursor. We already did the frequency on cursor. We just try to change the background color to white. You can just type CI, or you can just disable it from view settings. We came back to the demonstration workspace. Basically, you just turn this inverse background color. That means default is black. We wanna have white background. Then turn frequency on cursor. Now you have white background. Well, depending on your liking, and if you have multiple experiments, sometimes having some of the experiment in white background would be useful to distinguish different experiments. So let's say you have HNCACB, CBCA, UNH at the same time. You want to set one of them into white, and when you load strips, it will be easy to distinguish which one is CBCH UNH and which one is HNCACB. So we already done that. Now let's try to change the contours. You can use CT contour level here. CT, you can change in more detail the level, number of lines you want to see in the contours, color, if you want to change the colors, and then the spacing of the lines and the level to cut off the signal. So below that level you don't see anything. So you can change the options using contour setting. Instead, like I said, there is a single key that you can change. So semicolon, single quotation, and brackets combination with the shift key. This is easier way. So we will use this, but in case you want to go a little more detail and refine way, and then if you want to change the color, you will use this CT contour level window. But for now, let's use this easy method first, and then use this window, CT window, to change the color. So this is the hands-on exercise you will do. So let's change this red signals to this bluish color and change to white and purge all the negative contour signals. So you already changed to white background. So what we can do is using semicolon or single quotation mark. Let's try semicolon here. You can see that it's changing. Signal looks more sharper because the threshold level has been increased. So if you use single quotation mark, you can see that very weak signals or noise will be introduced that you don't want to see. And let's go back by hitting semicolon. You can see that positive signals does look better. And now negative signals, we don't want to see them. So like I said, you can hold your shift key and hit the semicolon, which makes the actual column. You can see that green contour lines are gone. Okay. And now we will type CT. This is the contour level window. And let's change the color. We can try tomato first. You see that the color has been changed. You can just try one by one. And actually blue to green. So depending on the intensity level, data height, gradient color has been applied, blue to green like this. So actually this was blue to green. So once you finish this exercise, let's move on. This is just the concept of the 3D data. Actually, you can change the dimension that you visualize the data. So we are dealing with NHSQC at the moment. So we see dimension 1 and 2. We don't have 3. And if you have 3D data, you will have another, this scroll bar down here. Then you can change the order, the dimensions that you want to see. You can change it by rotation and transpose. So rotation is XL. So you can just type XL, that is basically just change X, Y, Z. So X becomes Z, Z becomes Y, Y becomes X. That is rotation. So transpose is just changing between two dimensions that you are watching. So if you are viewing W2 and W3, if you just type XX transpose, just W2 and W3 will change. W2 and W3. So W1, in case W1 is the Z axis that you don't see, so you have it as a multiple planes to navigate, it will just stick there, only changing between the viewing axis by typing XX. If you type XR, it's a rotation. So entire dimensions will be changing. So if you type XL, XL, first dimension goes to here, second dimension will be here, and then third dimension will go there. So it actually changes everything. So you can just play around XL until you want it dimension to be put in the Z axis, and then you can just simply use XX to swap the axis between X and Y dimensions. So while we have NHSQC, just type XX to swap the axis. So we have second dimension and first dimension sitting X and Y respectively. If you just type XX, you see that W1 first dimension is at X-axis, and now second dimension is at W2. You can just type XX again to get that back. So you can do as many as you want to until a preferenced setup is accomplished.